Hi everyone. So we have already discussed like why we need to use logistic regression in place of linear regression. So we have done some we have plot some graph and see how can a sigmoid curve will help us in segregating between classification problem like positive classes and negative class. So let's understand the geometry intuition behind logistic regression. It is quite tricky and very much easy to understand, so I'll go in depth to understand what is the geometry intuition of logistic regression as well. So let's see. So as you can see, there is two classes like uh, positive and negative classes, right? So one straight line is actually segregating those two classes. So if you know linear algebra a little bit, so if you know linear algebra, so you can see like there is this plane. So plane means why I'm saying plane. What is the equation of line that we have seen in linear regression? That is y is equal to mx plus c in 2D line. 2D line basically means that we can draw that line in place of two dimensions. Suppose we have multiple dimension. So this is basically for multiple dimension. We have this equation for the plane, right? For the plane of high dimension. So it is represented as w transpose into x is the data points plus some bias. So w transpose is nothing but the normal. It is the normal to the curve. So it is nothing but the perpendicular distance, you can say. So it is part of linear algebra. So every plane actually represented as pi, and this is nothing but w. This is nothing but the normal to the plane. So this plane actually have some parameter w and bias. W is nothing but normal to the plane, as you can see. Okay, so yes, this is the parameter of this particular plane which is segregating two binary classes in place of high dimensions. So okay, this is the parameters, and x is the data points which is a vector in d dimension, suppose 2 dimension, 3 dimension. So it is a vector space. It is the data point is in the vector space, and w is the normal to the plane, that is also vector in the dimension, and bias is nothing but scalar point. So it is a scalar value in the plane. Okay, so what is our task in geometry intuition? What is your task? Our task is nothing but to find the pi. Pi means to find the plane which is best yes, which is best in segregating binary classes, to find this perfect plane. And how we are going to find the perfect plane? So each plane has these parameters, transpose tx plus bias. So if we are going to this is given, right? So this x is the data point, so you know that is given to us. So and this bias is nothing but, if this particular plane going through the origin, so this bias can be considered as 0. So moreover, if we can find this w w transpose, which is nothing but the normal to the plane, then we can find the plane, right? So we need to find the best w or the best plane which is segregating um, positive and negative classes, right? So okay, let's see another part. So I have taken one example where I have just taken all the data points that in our data, and we just try to uh, see, first the assumption of logistic regression is the all the data points are linearly separable. So it is as like we have assumption that all the data points are linearly separable. So that, but suppose we are taking this particular plane. So this particular plane is segregating those data points. It may be positive or negative classes. So we see all the data points has been segregated or has been segmented by this perfect plane, and this perfect plane has w is nothing but the normal. So every plane has some normal that is perpendicular distance. So w here the normal to this particular plane. And in the linear algebra that we know, the direction of the W would be positive. Like suppose it is the direction of W, so whatever the data points that are above this in the direction of the W, then it is all positive, and the down and the opposite yeah, opposite part of the W could be considered as negative value, right? So this is the basic assumption in linear algebra with the planes. And we are and also we are taking, so y predicted, like whatever the values are here, for positive classes we are taken plus one value, and for negative classes we are taken minus one value. So why I have taken this, I'm going to show you in the next, next part. So let's see. And it was like, you know that for binary classes we usually take 0 and 1. For negative classes we can take 0, and for positive classes we are taking 1. So here actually in place of 0 and 1 we have taken plus 1 and minus 1, and this particular y is nothing but this value that I have told you, negative 1 and positive 1. So di is the distance. So how to calculate this distance? Suppose we have data point here in the above the plane. So how to calculate distance? So it is nothing but W transpose, like whatever the normal to the plane is there, that is like each plane has some W. So W transpose into that particular data point divided by uh, that vector of W. W is nothing but normal to the plane. Suppose if we take this norm unit vector, so unit vector, you know that would be as 1, and we are taken, suppose this distance would be, suppose we have taken this unit vector, so this denominator part would be considered as 1, and we are left with this particular di. So this particular distance would be di. What is the value of di is nothing but W transpose into xi. Similarly, for the down part of the data points, as you can see, suppose xz is the one of the data points that is below to the plane. So how to measure the distance? So it will be same. So whatever the downside, whatever the W value in the below of the plane, that particular W value or transpose W transpose value in multiplication of this particular data point. Okay, so as of now we understood how to calculate this distance, like how to calculate the data points which are above the line and which are below the line. So yes, this is clear till now. So let's move the next one. Okay, so yes, as W is okay, so I have told you that if W is in the upward direction, so for, so in this plane, so whatever value with the direction of the W, that will be positive. So uh, the algorithm or the classifier predicted this, all these values are positive classes, and all this downside of the plane would be considered as negative classes as the direction of the W, which is the normal to the plane. Okay, so as this all are positive classes, so all the positive values, so this particular distance, so whatever distance of these values are there to the data points, that will be considered as positive values. Why positive values? Because W and xi are in the same direction. W means what? The normal to the plane. So it is in upper direction. So in that particular direction, whichever data point is there, that data point would be considered as positive value. And whichever the opposite direction of the data point, so these data points are opposite to the direction of the normal, which is W. So that distance will be considered as negative value. So this is clear till now. Okay, so that same thing that I have written here, that if wt and xi, so wt xi is nothing but the distance, right? So I'm writing the same thing. Wt xi, the distance would be greater than 0. Then okay, so this, if this distance is positive, the classifier won't see anything, just directly predict this as positive classes. And if the distance is negative, the algorithm directly predict as negative class. So which is value as for positive classes, the algorithm says plus 1, for negative classes minus 1. So this is till now, I think this is very much clear. So we'll see how different cases perform with different parts of the next problems. So let's see. So for this case 1, case 2, and case 3, some of the things that we're going to discuss in the next part. So it will be quite interesting to see, and all the doubts that you have in this particular thing, that will be clear with various examples. So stay tuned, guys.